All right, guys, let's see here. I gotta probably unplug this. Let's see what happens here. It may kick me out. It did. All right. Maybe not. Okay. It did not kick me out, it looks like. Let me double check. Okay, so we're good. All right, good. We are still good to go. Let's tackle this then. Okay. So we are getting into our first main calculus concept. Okay. So, and that's going to be limits. So the idea is this: we're going to base everything off a term called a limit. A limit is kind of like a boundary or a behavior. So I don't know if you've ever heard the expression "I'm about about" from your parents. I'm I am about at my limit with your attitude. What does that mean? It means that it's going to reach a point. Oops, a point where there is a boundary, right? Or where so this is a boundary, or where that behavior gets to a certain limit and a reaction piece happens where you don't know you get your car taken away or something like that. So when we talk about limits, when we're talking about limits in calculus, we're talking about behaviors and boundaries. Now, it's behaviors and boundaries of functions. So what we're going to find out here is that it's the behavior of the y value for this unit. So it's the behavior of the y value, okay, as it approaches a specific x value. So the idea is this. So I'm going to draw right over the thing here. Let's just say we've got this beautiful tree here, right? I'm going to go right over the top of it. And I got my little tree right there. And you can walk up from this side here and you can reach up and touch this exact point. So you're the x value and you're walking this way, okay? So you're the x value and you're walking towards the tree. And you can reach up and touch this part of the tree, this part in red right here. And then you are on this side here. Let's go to a different color. Let's go to, no, I already got green. Let's go to that color. And you're the x value on this side, and you're walking towards the tree. And you can reach up and touch this side. So if I can reach up and touch this side on the same height on both sides, that is the limit of what I can reach. So that is the limit of what I can reach. So that is literally the limit of the height that we have. So as I approach the tree and reach up, I can reach 7 feet on this side and 7 feet on that side. So my limit is 7. Okay. So basically, the idea when we start working our way towards you love my tree is we don't say a limit of a function. We say the limit of a function at a certain value. And this is the specific sentence you guys have to use right here. It's the limit of a function as x approaches a value. This key right here as x approaches. Okay. So let's kind of slide into it a little bit forward. This is what you're going to see it written as right here. This is the notation that you'll see. The limit as x approaches, that arrow means approach right here, c of whatever f of x is. So what we're saying is, what behavior does f of x display as it approaches c? C's the tree. So C's the tree, right? Here's my tree again. And as I approach C, or the tree, from both sides, What does my height do? Now remember, height goes up and down. That's got to be your y value. So what does f of x do, or what limit or boundary does it approach as I go towards each side? Okay, so let's just write this one out. So there's three basic ideas when it comes to limits. One is how you, well, I should say, let me rephrase that. There are three ways to solve limits. Okay, so finding the y value that you get as you approach a certain number. So if I was to take this piece here, this first problem, and I would say the limit as x approaches 2 of x plus 3. So let's just kind of draw this out real quick graphically. So I've got a y-intercept of 3, and this thing goes like that, let's say, right? It's 1 over 1. So this is my graph. So at x equals 2, right? At x equals 2. This is my only visual with a tree, guys. After this, there's no more trees. There's my tree, okay? Ugly tree. Now, it's asking, that tree is at 2. It's at 2. Now, if I approach the tree from the left and right, what is my y value? Well, you got three ways to do it. So at 2, what's the boundary? Well, this one I can plug it in. So I can end up saying, well, if, let me get my eraser here. Let's erase that one. I know that the limit as x approaches 2 of 2 plus 3, and that's going to equal 5. So my answer is 5. Okay? So then we put an equals 5. Okay? Because all I did was plug it in. I can plug it in because the graph is got a spot right there that I can see on the tree. Okay? Now, we end up with, let me erase that one there, guys. Let me erase my trees. I know, you're disappointed, but it's okay. So if I go over here and I look at this one, and you're like, well, let's try this one. And you're like, why? It looks harder. I don't want to do that. And I'm not drawing a tree, people. All right, so let me tackle that here. All right, so we've got this. Let's kind of, you can say it with me as I walk through it. The limit as x approaches 3 of x squared minus 9 over the quantity x minus 3. That's how you read that. That's a long sentence. Okay, so now let's look at this. Well, my first step is, let's try plugging it in. Okay, cool. So I go 3 squared minus 9 over 3 minus 3. I get 0 on the bottom. Doesn't work. Anytime you get 0 on the bottom, you may not plug it in anymore, okay? All right, so let's go back. Can't do that. So I can't have a 0 on the bottom. So what do? Well, I look at this. Let's see here. Let me factor it and then plug it in. So I'm going to take this bad boy and I'm going to say, all right, well, the limit as x approaches 3 of x minus 3, x plus 3, all over x minus 3. Well, I can go, oh, look at that. Those cancel. And so now I get the limit as x approaches 3, and yes, you got to write it all the time, of x plus 3 equals my plug-in point, 3 plus 3, which is 6. So my limit is 6, okay? So step 2, if you can't plug it in, you're factoring and plugging it in, okay? So let me show you here real quick, and I won't do you can plug it into Desmos or your calculator, and I'll show you on your calculator on these tomorrow. So we're going to do a little bit of calculator work to help you guys out a little bit, all right? So let's tackle this bad boy. So if I was to graph this, all right, This is dumb because I'm not good at it. All right, there we go. If I was to graph this, and you know what? I'm tired of drawing horrible lines. So I'm going to go my x-axis, and then I'm going to go my y-axis. There we go. Good. Woo! I feel better about myself. All right, so here we go. So if I was to graph this, lo and behold, it actually is the same exact line that we had here. Because remember, if you look at the notes that you took, I have x plus 3 left. So I have x plus 3. So my y-intercept is 3, and it goes up in a straight line like this. And then since I'm not very accurate, I just draw a bigger dot. There we go. Now I'm covered. All right, now it's approaching 3. But I also know that 3 makes the bottom 0. So what we have is a missing spot in this thing. And I don't think I can do that. So I'm going to be honest with you. I think if I try to erase it, it's gonna make a big spot right there. I mean, it's going to erase the line. So what it does, and I'll do it in blue here. If you do this on Desmos, it should put an open dot right there. If not, I'll show you in class a little better. So now all of a sudden, I have a graph that's going along just fine, and then there's a missing spot for where this doesn't work, and then it just keeps going. So as I approach from here to here, as I approach from the left and the right to 3, what does the y value become on each side? Well, it gets closer and closer and closer to 3, and it gets closer and closer and closer, to 6. So the limit, or the height I can possibly reach, the boundary it's closing in on, the behavior it's exhibiting, what behavior is the y value exhibiting? It's approaching 6, okay? That's why the limit of this equals 6. All right. So now, here's our next. Oh, that didn't work very good. Here's our next one. Then we get something like this butte right here. This butte is ugly. Can't factor it. If you factor that, you probably did something wrong because it's not factorable. And so we get this idea, if I have it factorable, not factorable, I go like this, and I'm going to graph it out. And actually, let me go Z because I've graphed this thing out. So this thing right here, it should, let me graph it out again real quick. I'm going to graph it on my calculator. I'm going to show you guys this one tomorrow too. This one's a little easier to, oops, wrong mode. All right. So we are looking at, sorry guys, I would fast forward for a little bit until I start writing, just to be honest with you. Oops. All right, hold on, guys. It's not graphing right. So what should happen here is, here it goes, right there. All right. So what happens here is we get this goofy looking graph that goes like this. Oops, that is not the right thing. Let me draw it. So if you graph this on your calculator, and we'll show you how to do it tomorrow, you get your goofy little graph that just like takes off and it goes down like this, right at 1, right? So right at 1, it does something crazy like that. And I hope I didn't make up a problem that totally gets jacked up. So let's find out here. So you might want to fast forward until I start writing again. So what I'm doing right now, just so you guys know, is I'm changing the table values so I can see it. And we're going to do that in class tomorrow. So it's going to be approximately 300. So that's the limit. So way down on your calculator down there, it approaches a value. And I'm going to show you how to do that on your calculator. So the point behind this one is, sorry about that, guys. I picked a really bad example. Is that if you cannot plug it in and you cannot factor it and plug it in, you're going to graph it on your calculator, and we're going to use the calculator to find it. Now, this in particular, I'm going to show you in class tomorrow. It's a lot easier to do in class, so I can answer questions. Okay, so we're going to do that one in class tomorrow. All right, so we have the idea behind one-sided and two-sided limits. This will be also a discussion that we're going to do in class tomorrow, but I'll kind of give you the heads up so you can kind of check your answers. So if you can see that, and I don't know if you can, that is a little plus on it right here. Okay? See how it says x approaches from the right to, x approaches 2, and it's got a plus, and I can't draw a plus very good. I'm talking about this one right here. The plus means it's coming from the right. A minus right there means, so a 2 minus x approaches 2 with a minus sign, it's approaching from the left. Okay? And when there's nothing, it's approaching from both sides. So when there's nothing, that means it's approaching from both. So they're called one-sided limits, or a two-sided limit. So our one-sided limits are the plus or the 2 minus. The two-sided limits are just the number itself. Okay? So let's just kind of walk through the first one for you. And we're going to look at the first one. This says the limit. So we're going to read the graph. The limit as x approaches -2 from the right. There's that positive sign right there. So x approaches -2 from the right. So if I go to -2, I find my closest, I find the line that is directly to the right of it. Not the green, because that starts at 0. I literally want to know what's going on at -2. So I pick the blue line. And then I follow along to the left like this because I'm approaching from the right, so I'm moving left. So I'm walking up to the tree only from the right side, okay? And I look at it and I go, how high can I reach at that particular point? Well, I've got a solid dot on the blue line. That's my Y value. That's going to be a 2. So that's going to equal 2, okay? So you guys can try these other ones, and the answers are right here. And that is the end of the video for today. And we will see you tomorrow.